Let's summarize what we've talked about with respect to polar graphs, and then we'll practice graphing a few. So let's look at circles. Here are just a few examples of the equations of circles. Here are how the equations look in general, and I have a few specific examples. When you have r equals a constant, we have a circle centered at the origin or the pole. If we have r equals a constant times cosine theta or a constant times sine of theta, we have a circle that is tangent to either the x-axis or the y-axis with one point actually lying on the pole. We've also talked about rose curves. Now the equation of a rose curve looks like this. R equals a times cosine n theta, or r equals a sine n theta. And whether n is even or odd helps determine how many petals you have. If n is odd, you have n petals, and if n is even, you have 2n petals. And here is just an example of two different graphs that would be rose curves. The cosine or the sine helps determine what the orientation is of the graph, and the A is going to tell us how long each petal is. Here it was 4, so our petals are each of length 4, and in this equation each petal is of length 13. And on this one we would have 3 petals, and this one 2 times 2 petals, or 4 petals. We've also talked about limacons. General equation of a limacon would look like this, where A and B could be positive or negative. So notice right here, this does not imply that B has to be positive. I have a few examples of what a limacon could look like. When A and B are the same values, then we have a cardioid. It's just a special case of our limacons. Here's one with an inner loop, and here's one without an inner loop. So let's practice graphing. Let's start with the basic, r equals 5. And I have a little polar grid right here. Let me pull it down so you can see it. R equals 5. Remember, that means for all the ordered pairs that exist on the graph, the r value is 5. So that could be 5, 0, 5 pi over 4, 5 pi over 2, 5, 4 pi over 3. And you can continue and you would find all such values. Oops, not that one. That was 4. Here we are at 5. And we would connect all these points, and you find that you have a circle with radius 5 centered at the pole or the origin. When r is negative, we can consider the same thing. Now, if you have negative value, consider what the ordered pair would look like with polar coordinates. Our r value is -3. So -3, 0, for example. I'm looking at an angle of 0 radians, but I would back up 3. So I'm here. -3 pi over 2. I would look at pi over 2 and I would back up 3, and I'm here. Or 2 pi over 3, if I were looking at 2 pi over 3, and I went backwards 3 units, I would be here. I was saying this point. And you'll notice you end up with this circle, which is completely equivalent to r equals +3. So r equals 3 or r equals -3 would generate the exact same graph. Typically, you would see it presented as r equals 3, though. Let's do another one. Let's graph r equals 8 cosine 3 theta. I hope you recognize it as a rose curve. So as we've done before, I'm going to graph first the rectangular graph that relates to this. So I'm going to graph y equals 8 cosine 3x. And then we'll translate that into a polar graph in a moment. So when I'm considering this graph, I know that the period is 2 pi divided by 3. So at 2 pi over 3, I will finish one cycle. At 4 pi over 3, I'll finish another cycle. And at 2 pi, I will finish a third cycle. So let me graph these. Let me cut it up into quarters. Here's my cosine graph. Starts up here, comes down, and back up. An amplitude of 8. It's good practice for graphing your rectangular graph. So it comes down and comes back up. And of course, it would do that for each cycle. So I've come down and back up. And I come down and back up. So here's my rectangular graph. This is x, this is y, and now when we translate it, we're gonna think of this as theta, and this is our r value. So I need a polar grid right here. We're gonna use, we'll need to move the camera up just a little bit so we can see it. And we need some key points. Remember, I'm hoping you recognize it as a rose curve, and it's nice to know that it's a rose curve. Some of our key points, though, which will help us find the places where the graph will be tangent to some particular lines. Remember, they were the places where the rectangular graph has x-intercepts. So let's find those values. This is 2 pi over 3. That makes this pi over 3, and that makes this pi over 6. So let's label this at pi over 6. So this is 1 pi over 6. This is 2 pi over 6. This is 3 pi over 6, or pi over 2. 4 pi over 6. 5 pi over 6. 6 pi over 6, which is of course pi. 7 pi over 6. 8 pi over 6. 9 pi over 6. And we know 9 pi over 6 is 3 pi over 2. 10 pi over 6. 11 pi over 6. And of course 12 pi over 6, which is 2 pi. So I just wanted these values because these represent places where the graph would go through the pole, just as the rectangular graph goes through the x-axis. Our rose curve will go through the pole at those points. So I'm going to, or at those values, I'm going to put in the lines that would be represented by pi over 6. So let me put that in, and I extend it all the way across the graph. At pi over 2, let's extend that across the graph. So these will help be my graphing guides when I'm graphing this rose curve. Did I leave off 5 pi over 6? And then I'm at 7 pi over 6, and notice that's the duplicate, so is 3 pi over 2, and so is 11 pi over 6. So these will help me graph my rose curve. Now I'm going to be looking for the petals. Notice between 0 and pi over 6. Let's start there. At the angle 0, the radius is 8. So let's see, we'll go 2, 4, 6, 8. We're out here. And between 0 and pi over 6 Notice our R value goes down to 0. And it's going to approach this line right here. We know the angle we're approaching the pole at will go right along here. It will be tangent to this line. So I'm coming along here and I approach the pole right along this line. And I'm going to cross through the pole at that same steepness, just along that line. So now I'm over here somewhere. Notice between pi over 6 and pi over 2, the R values are negative. So between pi over 6 and pi over 2, this angle, these angles right here, I go across the pole because our values are negative. That means I'm down here. And we're going to go down to -8. So at pi over 3, I'm at -8, so I'm over here. So 2, 4, 6, 8. And remember, this much of the graph represents one petal. So I'm going to label this as petal 1. We only had a half a petal there. So, oops, it's a little bit too narrow here, but let me have the graph. And it will come back in at this angle. We have that as our graphing guide. So here's how our petal looks. Now look, we have another petal between pi over 2 and 5 pi over 6. Pi over 2 and 5 pi over 6, and the R values are positive. So from pi over 2 to 5 pi over 6 right here, my R values are positive. They'll go out to 8 and come back to 0. So from here, I come along this line, but I'm going out to 8. 2, 4, 6, 8. Going out to 8, and then I come back, and I'm coming along this line when I get close right here. And this was petal 1. This is petal 2 coming from this piece right here. Now petal, I said 2, but I wrote a 3. That's petal 2. From 5 pi over 6 to 7 pi over 6. So we're talking about from here to here. Notice our R values are negative. So from 5 pi over 6 to 7 pi over 6, we go across the pole, across the graph to the other side. We're over here. So as I came down, my graph went up here and came down. It crosses through, and now I'm over here. And I complete this petal, and now notice I'm starting to repeat the first half of the petal that we'd already done. So this represents petal 3 that we just did. And it started to repeat that half a petal that we had right here. This would repeat another petal, this would be a repeat of the petal, and this would be a repeat of half of a petal. So we, in fact, have the rose curve done right here. Let's do another one. Let's graph R equals 6 plus 6 cosine theta. I hope you recognize this as a limacon. We're going to start by graphing y equals 6 plus 6 cosine x. So we know what the graph looks like. We know 6 cosine x is our cosine graph with an amplitude of 6, but it's been shifted up 6 units. So let's see what that looks like. The period is unchanged, so it's just to 2 pi, right? And we'll just finish one cycle between 0 and 2 pi. Normally, this graph with 6 cosine x would exist between -6 and 6, but we've shifted it up 6 units. So it will exist from 0 to 12. Right, and here's our midline right here. Here's 6. So our graph would look like this. Let me get some intermediate values here. Here's pi. Here's pi over 2. Here's 3 pi over 2. So if we start at 0, you can even substitute a 0 in here. Cosine of 0 we know is 1 times 6 is 6 plus 6 is 12. Just as we expected, we're starting up here. We know what the graph looks like. It will come down and then hit the x-axis at pi, and then it will come back up like this. And again, good practice for graphing your rectangular trig functions. So here's a picture of y equals 6 plus 6 cosine x between 0 and 2 pi. Remember, this is x and this is y, but now we're thinking about these being our theta values and these are our r values. So let's get some key points listed here. At 0 radians, we would be at 12. So let's see, if this is 0 right here, 2, 4, 6, 8, 10, 12, right out to here. At pi over 2, our r value is 6. Pi over 2, our r value is 6, 2, 4, 6. At pi, our r value is 0. Pi, so I'm looking this direction, but I don't go out at all. And at 3 pi over 2, my r value is 6. So now I'm looking this direction and the direction of 3 pi over 2, and I go out 6 units, 2, 4, 6. And at 2 pi, I'm back to 12. So 2 pi, I'm looking that direction and I'm back at that point. And then the graph would start to repeat. Notice here that there is nowhere on this graph where the graph actually crosses the x-axis. So there is nowhere on this polar graph where the graph will cross the pole. It's going to touch the pole as it touched the x-axis, but it won't cross. So I don't have any lines to draw for lines of tangency. But now let's figure out what the graph looks like. Let's start between 0 and pi over 2. Our r values are decreasing from 12 to 6. So it starts at 12 and they're getting smaller and smaller and smaller until we get to 6 right here. So as I've shown you before, usually pick some point to give myself a sense of how wide or narrow this is. Does it come in this way? Is it a little bit wider? So for a cosine graph, I would probably pick pi over 3 because we know the cosine of pi over 3 is a half. So if we look at pi over 3, so I'm just plotting that point, r and theta, and I'm putting pi over 3 into my equation right here. Cosine of pi over 3 is a half. A half of 6 is 3, and we have 3 plus 6, which is 9. So I have 9 pi over 3. So pi over 3, I'm out at 9. 2, 4, 6, 8, 9. So the graph would look something like this. It's coming around this way. But because we know about the cosine function, we can easily put in 5 pi over 3 as well. You know 5 pi over 3 would also give us that value of 9. So let's put that into 5 pi over 3, 9. 2, 4, 6, 8, 9 right here. Might as well put that point in. Now we'll draw that part of the graph in a minute. We've looked between 0 and pi over 2. Let's go from pi over 2 to pi. So what's happening from pi over 2 to pi? The r value is getting closer and closer and closer to 0. So as I move toward pi units, My R values are getting smaller and smaller and smaller. I'm getting closer and closer and closer to the pole. So you can put in a value. We could just draw a sketch. We know it looks something like that, but if you want the graph to be a little more precise, we can put in a value like 2 pi over 3. We know the cosine of 2 pi over 3 is -1/2. So 6 times -1/2 is -3, plus 6 is 3. So at 2 pi over 3, I would be at 3. So that's 2, 3. And it just gives my picture a little more clarity on what it would look like. So it comes out to here and comes in to here. Similarly, I should have put it the 3 right here. Here's my R and theta. Similarly, if you put in 4 pi over 3, you'll get 3 as well. So let's put in that point right here. So between pi and 3 pi over 2, your R values are getting bigger. Between pi and pi over 2, my points are getting further away from the pole. I'm at 0, now I'm at 3, now I'm at 6. Notice the R values are going to continue to get bigger. Now I'm at 9, keep going, and pretty soon you'll be up at 12. And we have our cardioid graphed. Let's do one final graph. Let's let it be this one. R equals 8 cosine theta. I hope you recognize that as a circle. And the more you recognize, the easier it is to just come up with the graph pretty easily. But I'm going to treat it like I did the others. I'm going to graph y equals 8 cosine x, which we could graph pretty easily, I hope. 0 to 2 pi. We know that it looks like this. Amplitude is 8. So it's up here, down here, and our graph looks like this. Here's pi. Here's pi over 2. Here's 3 pi over 2. Remember the places where the graph crosses the x-axis. And I'm thinking of this as theta and this is r. The places where the graph crosses the x-axis is where the graph would be tangent to a line. So let's look at our line of tangency would be pi over 2 and 3 pi over 2. So pi over 2 is this line. Well, and 3 pi over 2 is that line as well. So our graph is just going to be tangent there. It's going to go through the pole along this line. So let's see what our graph looks like. At 0 radians, we're at 8. 0 radians, we're at 8. 2, 4, 6, 8. At pi over 2, we're at 0. So between 0 and pi over 2, it has come to the pole. And we know that it's coming this way. The R values are getting smaller and smaller and smaller. And right along here, the graph will approach the pole along this line. And it will cross through right along this line. That's why we drew that line, and that line is going to be tangent to our curve. And I hope you recognize again that this is a circle. So we know what it looks like already. It comes this way. You can plot a point if you like to make sure the circle looks a little bit better. I'm going to put in pi over 3. Cosine of pi over 3 we know is a half. A half times 8 is 4. So at pi over 3, I'm at 4, 2, 4 right here. So my curve could look like this. right? It's tangent right here along this line. And we might as well put in 5 pi over 3 as well. We know that right here it's going to be 1, 2, 3, 4 also. And we would have a circle that looks like this, right? From pi over 2 to pi, so from pi over 2 to pi, our R values were negative. That's how we finish up the circle. So from here to here, we have finished the circle, and the rest of it just repeats or duplicates that circle. So R equals 8 cosine theta looks like this. I hope you're able to go practice some polar graphs.